value of the f inverse if the function has been given. Okay, so given f, all right, we want to find the f inverse. Okay, so we have been given this function f inverse of x, f inverse of f of x, right? So from this definition, we can see that this takes of this, and we can say that this is equal to x, right? So that is the expression derived from the given function, right? So two, the derivative of an inverse function is given by 1 over the first derivative times the inverse of the function. So 1 over the first derivative, then inside the first derivative, you see the inverse of the function. That is the derivative of an inverse function. The derivative of an inverse function is given by this. Okay, have a function and we want to find the domain. So the first thing we have to do is that we have to check if this expression under the root sign is real, right? So we try to say that 4x plus 1 should be greater or equal to 0, because any expression under a square root sign should be greater or equal to 0. When it is less than 0, you're going to have a complex expression, and you can't deal with that at this point here. So we have greater or equal to 0, any expression under the root sign. So we're going to have 4x greater than or equal to negative 1. So we have x is greater than or equal to 1 on 4. So that is the value of x that we are going to exclude in our domain. Okay, so the domain for this particular expression is going to be domain of f. Domain of f is going to be negative 1 to positive infinity. We exclude these values so that we can define this expression. So the domain of this particular function, the domain to this particular function is negative 1 and infinity, or exclusive. So the reason why we chose negative 1 is that when you put negative 1 here, you're going to have minus 4, right? Minus 4 plus 1, right? Minus 4 plus 1 is going to be minus 3, right? And root of minus 3 is complex, so we don't accept the minus 1. All right, so that is the domain to this particular function. Problem number 3. We want to check if this particular function has an inverse, right? So how do we do that? If you want to check if this particular function has an inverse, then the first thing you have to do is that this expression you have here, s greater than or equal to negative 1 on 4, x plus 1, right? So this expression, which is equal to f of x, should be a one-to-one function. And from here, from this point of view, we can see that this expression is a one-to-one function. So it satisfies the condition of becoming an inverse function. So this is the inverse exists, right? Let me go over again. For the function, and from here, from this point of view, we can see that this expression is a one-to-one function. So it satisfies the condition of becoming an inverse function. So this is the inverse exists, right? Let me go over again. For the function to have an inverse, then it must satisfy the one-to-one condition, right? So it must be 1 to 1. Okay, so this, the function f, the inverse of this function exists. The inverse of this function exists because it's a 1 to 1 function. All right. Problem number 4 is we are going to find the range of this particular function, right? So the range to this particular function, we are going to include 0, but we exclude infinity, right? Positive infinity. So we include 0, the range of this particular function, the range of f of x is 0 inclusive, then we have our positive infinity exclusive. So that becomes the range to this particular function we have right here, right? So move to problem number 5. Problem number 5. So we want to find the inverse of, okay, so we solve for x in terms of y. So we're going to have x equals y squared minus 1 all over minus 4 all over 4, right? So we have x equals 4 squared minus 4 all over 4, and that is equal to 16 minus 4 over 4, and that is 12 over 4, and that is 3, right? So we have x equals 3. That is equal to x is equal to 3. So the value of x is equal to 3 at y equals 4. At y equals 4. So that is